Hello everyone, I'm Sebastian, I'm a developer at Jane Street. And today I want to talk about OCaml as the ultimate config format. Or more specifically, I want to talk about a library called OCaml plugin that we built here at Jane Street that allows you to solve the configuration problem in, I think, in a fairly neat and useful way. So let me start up by sort of talking a little bit about the requirements we have here at Jane Street and what we want out of configurations. So firstly, we have a very high systems to developer ratio, meaning we have a lot of systems to be taken care of, and only maybe on the order of like 80 to 100 full-time developers are responsible for them. We often want to quickly adapt our existing systems to changing requirements. So that could be we have a new strategy we want to implement, or we have some new regulation we have to comply to, or there's an unusual spike in trading today, so we quickly want to reallocate a bunch of resources from our systems. And crucially, we want to do so, we want to make sort of fairly intrusive changes to our systems without having to go through the cycle of coding, testing, reviewing, and deploying every time. So what we want to is we want to have sort of flexible and configurable systems that allow you to make fairly big changes to the functionality without sort of having to actually write code for it, and everything should go via configurations. So at Jane Street, we try to think very carefully what should be configurable at the time of development of the program. We think very carefully where should the line be and like what expressiveness should we give to the user. So let me talk about what the configuration problem now actually is. The configuration problem, you could say, is the problem of how to express configuration in a way that is both powerful and flexible, such that the user can like do all the things he wants to do with this, and also it's flexible enough such that when you originally start out with one use case in mind, you have a chance of later sort of like adapting to other use cases fairly quickly. And on the other hand, the configuration should be maintainable, such that it doesn't take an absolute expert to even touch the configuration and understand the configuration. So very often, configuration languages for your systems start out fairly simple and fairly easy to implement, and you have like a use case in mind that you want to use this for. And it's fairly straightforward and intuitive. But as users request more features, because your language is sort of like too restrictive in the beginning, it quickly goes in complexity very sharply. To the point of maintaining this configuration language becomes very hard. And it becomes especially hard when you have many different systems with different kinds of configuration or different ways of expressing configuration. So maybe if you have like 2, 3 systems in production that are like fairly complex mature systems that you need to configure in a non-trivial way, maybe that's about doable. But if you have like 10 or 15 or even more, like it just doesn't scale. And you don't want to be in a situation where every time you want to make a change to a production system's configuration, you sort of have to have one expert that's the only person that's allowed to touch this configuration. So let's take a simple example. Let's talk about a mail server and how the configuration problem applies there. So this is a simple design of a mail server. Messages come into one end. You have this core, which we call handle message, which sort of you parse a message, you might transform a message in various ways, and then you make a decision what to do with this message. So simplified, you could say, well, either you deliver this message to a user's mailbox, or you relay this message to another mail server, or you just reject this message. So what can you configure in email? Of course, you can configure a lot of behavior and customize a lot of behavior. So you can configure things like spam filtering and virus blocking. You can like automatically expand mailing lists in various ways. Maybe you have some requirements from compliance or regulators to log very explicitly your mail traffic, such that like everything that gets delivered to any user's mailbox is like guaranteed to be logged somewhere in a persistent state. And many other things, and I'm sure most of you are sort of like familiar with the various ways of like being able to configuring even just your Gmail inbox, right? And there are like some standards in this world, and there's some standards about messaging, but there's a ton of configurable behavior. So, and in this case, sort of the handle message thing, the thing in the middle, the black box, would be responsible for like making these decisions and applying this behavior and being able to customize it. So let's say we want to do this like with an example using Exim, a very sort of well-known mail server software. And if you wanted to like just start like very straightforwardly, you probably have a configuration that looks like this. So at the top here, so by the way, like the syntax and the exact meaning doesn't mean too much, but this is just as an example. So on the top, you would define a delivery method, meaning what do you do for mail that is being accepted into your mail server. And you simply say, well, in this case, you append a file, and you append the file var/mail/localpart, where localpart is a variable bound to the thing that comes before the @ So if my email address is sebastian@gmail.com, then the local part is just Sebastian, right? And then in the second part of the configuration, you sort of define how to actually accept messages. So you say, in which case, here the crucial part is the local parts bit, which looks a little bit like a variable definition, but it's actually not. It's choosing an option from the Exim configuration. And in this case, local parts search says that, well, when we accept the mail, we want to look in some file, in this case, var users, for the local parts. And if the local part is in there, then we deliver it, otherwise reject it. So the idea is we have like a file of users, and we search through it, and every time we get a mail with the username, and if it's there, we accept it. And if not, we give some error message of saying the user is unknown. Right, so this is pretty straightforward, and if you sort of like spend a little bit of time with Exim's and Exim's manuals, then it's not hard to work this out. So now let's say we want to add sort of one other feature. We want to be able to allow plus suffixes. So for those of you who don't know, there is actually a feature, the same feature is in Gmail, which is that you can append a plus and anything else to your local part when you send an email, and it still gets delivered to the same address. So if my address, again, is sebastian@gmail.com, you can send me an email to that, or Sebastian plus, say, GitHub, or something else, and it will still get it delivered to me. So everything after the plus is ignored. And let's say we want to kind of implement this little feature as well in our server configuration. And then you browse the manual a little bit, and it turns out it's not too hard. There's this thing called local part suffix, which allows you to do this. And here you just set the local part suffix to be like this thing +*, and you say, of course, it's optional, because you don't have to have it. So that's actually not very hard, but it already starts to raise a few questions. So this +* thing looks like a regular expression. Maybe it's just a sort of a shell glob, but it's not quite clear what it is. And in this case, yeah, it's pretty straightforward, and you can like pretty intuitively realize what it's doing. But if you had a more complex use case, I wouldn't be sure how that actually works. And another problem is, well, does the ordering matter? So like in this case, like could I have put the local part suffix thing above or below as well, or does it need to be exactly in this case? I don't know. And now let's say, well, we want to go one step further and say some users don't want this plus suffix feature, so we want to disable it for them, right? So let's say you can do this with a condition in Exim. So you would say something like, well, if the local part suffix is defined, then if it's not defined, then of course you can deliver it. If it is defined, you look in this file allow plus, and you see from your local part data, which is the local part gets assigned to, and you check whether or not that's yes, right? So a few other things here, which are sort of non-intuitive, is when you expand variables, like up there in local parts or down here in local part data, you use the $. But when you check whether or not a variable is defined, you don't use the $, right? So that's not quite obvious. And another thing is like this local part data, like that's a variable that sort of magically sets by the fact that you use the local parts option above, right? So like that's not obvious from this configuration at all, but it just happens that Exim makes this guarantee for you. And now, sort of, if you want to like make a error message a little better, well, we have to have another condition. And because we can't sort of arbitrarily define variables, we kind of have to repeat a very similar condition to above to be able to distinguish between unknown user and user doesn't allow plus suffixes. So, by the way, I'm not trying to sort of make Exim look bad or say Exim is a bad piece of software. And on the contrary, like we very much rely on Exim and use Exim for a lot of things. But I'm just trying to hide like general problems of like if you have some sort of DSL in your configuration language, things can very quickly get very complicated. And there's very often the interaction between different features that each of their own is probably fairly straightforward, but the sort of overall complexity comes from the interaction between these. So, of course, this was just the tip of the iceberg, even just the tip of the iceberg for Exim. Because like Exim has a huge pipeline. There's a ton of things it does, and at each stage you can have customize some behavior. So the Exim configuration really is quite large, and takes a lot of time to actually understand what's going on. And of course, often like things between different stages are not independent, right? Like if you do something at a certain stage, that might have implication for later stages. But again, Exim itself is a great piece of software, and in this case, well, Exim has a very well-written manual and is well-documented and well-tested. And Exim even has like a little sort of hard copy of a manual you can just buy in a bookstore and read, which is not going to be true for your own production system, right? So like if it's a system you write at your own company, you're probably not going to write a book about it. So documentation in this case is very good, but in most cases probably not nearly as good. Okay, so what's the problem with these kind of configuration DSLs? In general, so one problem is the complicated semantics. We've seen that, like, well, what happens if we change the order of these things? Does that matter? What happens if we do? Another problem is like the error handling. So one error we didn't talk about beforehand was, well, what happens if the user is not in that var users file, right? Presumably Exim doesn't crash and just sort of gives an error message. But like, what error message does it give you? Because the error message we defined were just that the user is not that the user doesn't apply to the unknown as user. So it's not quite straightforward what happens in that case. Another example is that these side effects things of like, well, if you choose a local path configuration option, that magically sets some variable you can later use. Right? Another problem with DSLs is the poor semantics. The poor tooling. This is a problem of like, well, the fact is my examples weren't sort of used any syntax highlighting is not just because I was too lazy to do it. It is also because it's like, there's not straightforward tooling that just allows you to do it. There's probably something that does it for Vim, but like I couldn't find an easy way of actually making this work in this presentation. And another example is, well, if you imagine some big complex configuration and you have like one part that sort of like is known to like do this like fairly complex but small thing, like intuitively you just want to write some sort of test that says like feed a bunch of input into it and see that the output always matches. But that's kind of hard to do with configurations because you can try to like extract that a little bit into a different standard configuration and then feed some data into your system and make sure it behaves. But it's going to be hard to actually exercise all the cases. And there isn't an easy way to sort of write inline functional tests. Right? Another problem is that it often requires sort of domain-specific knowledge and experience. So there's a difference between knowing how email works and knowing how Exim works. If you want to configure a complex mail server, of course you have to know something about email. That's sort of inevitable. But ideally, you wouldn't have to know the sort of exact details of Exim. You don't need to know sort of what Exim's model is of passing various messages. Ideally, you could sort of at least read a configuration and make sense of it when you know something about email without knowing anything about Exim. Then another problem is the discoverability. So with all these things, it's not easy to, like, there's not a sort of a good way of being able to find functionality that exists. So in the Exim case, you could read the manual, but it's pretty long. In sort of your standard case of your own system that you build, there's probably no documentation. So it's going to be pretty hard to figure out like what features are actually available. And finally, there's a problem around culture. So the problem around culture is that configurations aren't aggressively refactored as they become easier, right? And as I said, you can't really sort of nicely test configurations. Another problem is that there isn't really any sort of styling guides around configuration. So you might say, well, people can't agree on a styling guide for code either, but at least there, like people care enough to even argue about styling guides. And no one cares about sort of a styling guide for configurations. And finally, there's also like, there's not a process of reviewing configurations very much. So configurations tend to sort of grow very large and complex and sort of like over time sort of a fairly nasty pile of a mess that sort of people are afraid of touching. And this frustrating part about all this is that it kind of feels like, oh, we are sort of running into a problem we've already solved somewhere else, right? So we have tools, like we have a thing that has great semantics and well-understood semantics and good tooling and great discoverability and a good culture. It's like our programming language, right? So let's say what happens like if you were to just write Exim's configuration in OCaml, right? That would be pretty easy. And it would be pretty sort of easily readable if you know OCaml. So you would just sort of define your handle message function, and you would sort of take your local part that you sort of extract as a function, and you would split on the plus, and then you would look up that user in this user file. If it doesn't exist, you reject. If it does exist, you have the preferences, and you can check if the suffix is there, and if the user allows the suffix, in which case you continue, otherwise you reject. And now it's a fairly straightforward and like easily readable thing. If you know OCaml, like you can make sense of this configuration without knowing anything about Exim, right? But that's not really sort of a fair comparison, because like now it's sort of like on the left-hand side is configuration, on the right-hand side is just code. And of course I can write things more concise in code, but that doesn't get me like the same flexibility as configuration, because well I had to write code to do it. But that's the point. So that is the point of the library that we've built. The goal of it is that you can use arbitrary OCaml code as your configuration, and your system sort of dynamically loads and reloads this at runtime. So if you're familiar with Python, this is a little bit similar to the eval function, which just sort of takes a string and interprets it as code and runs it. But OCaml doesn't quite sort of have exactly that expressivity, that power. It has something else though. But in general, the idea is we want to use code as our programming language. So how do we do this? As I said, OCaml is statically typed and obviously compiled, so it doesn't have just a nice eval function that Python has, but it has something called dynamic linking, which you can use to do this. Basically, the type of dynamic linking is just you take a string, which is a compiled file name, and it sort of takes that file name and runs it inside your own process, and then returns yield in the end, right? So it just loads the program and executes it inside your own process, and that's it. And if you want to then communicate with the rest of the program, you can use side effects. So if you wanted to do this handle message example, well, we could imagine having our mail server look like this. So like define some reference, handle message reference. And then in the actual function of handling message, you dynamically load your file, and then you dereference this, hoping that your plugin has set that reference. If it doesn't, you fail. If it does, you have the handle on what the plugin or the configuration wanted to do. And this works, by the way, because the plugin sort of gets loaded and executed inside your process, and like having access to all the same top-level definitions that you previously had. And this almost gets you there, but it's not really quite nice, because there's no clear interface between the main program and the configuration or the plugin, right? And you only sort of catch mismatches at runtime. And runtime here means the runtime of like the actual execution of the thing, which could be well after the loading of the plugin or the configuration, right? And you also still need to compile beforehand. So it doesn't really solve the problem yet. So, and here, in this case, like here's the plugin, which would literally just define this much and then set this reference. So what is it that we really want? We really want a clearly defined interface between our application and our configuration. Sort of a clear contract on each side, what is provided and what needs to be implemented by this thing. Right? We want to write our configs as straightforward ML files that using our sort of existing and comfortable dev environments. And we want to have our systems load and reload these ML files at runtime dynamically. And this is where OCaml plugin comes in. This is the library that we wrote here at Jane Street, which sort of solves this problem and does exactly this for you. So what it does is it compiles and executes OCaml source files at runtime. It returns the plugin as what's called a first-class module. So I don't want to go into too much detail exactly of what that means. It's a sort of fairly OCaml-specific idea, and it applies to in other languages, like a similar concept would apply in other languages. But the idea of a first-class module, just to mention it, is OCaml has like the basic syntax, and then it also has sort of a module syntax that sort of is fairly separate to this, that lets you define like various modules with like abstract interfaces and then implementations and various ways of referencing them. And normally these two things are like separate, or sort of like not really working together. But there is a way in the OCaml language where you can make modules be sort of first-class things, first-class values, so you can pass them into a function or stick them in a hash table or something. And this is what the idea of first-class modules. And the third thing that the library does is sort of it embeds the compiler and all the compiled libraries into the executable as well, such that you minimize any dependencies you might have on the target system. Because it'd be kind of awkward if in the middle of like loading a plugin, you realize, oops, this plugin needs a compiler and a library which is not installed on the system, so I can't do it. Okay, so let's say we want to go back to this mail server example and do this with OCaml plugin. So let's first define the interface, and that's pretty straightforward. So what you do is you define a module type, which I did here at the very bottom, called mail server config, and that just that is the contract between the plugin and the main application. So in this case, you just have a simple function that says handle message, which takes a message, which is some record type here at the top, like including a bunch of information about the message, and it has to return a response saying one of the three things: it has to say delivered, relay, or reject. Okay. So here it is very clear what is the input to the plugin, like what information is available to the plugin, and what are the obligations of the plugin. So now let's say in our main mail server, we want to use this OCaml plugin. So here's a bunch of sort of like the code to make this work. You define a module plugin, which, and then here's where it gets a little bit OCaml technical. In this case, you have defined this type T in this module, which itself is a first-class module, which refers to this module type. And then you have the plugin loader by calling into OCaml DIN loader, which is a thing provided by OCaml plugin. And now, when you actually run the function, like in your main function, you can just load your arbitrary ML file, and then you have to do this thing of like unpacking the first-class module in a way that sort of like has the syntax, and you have to give it this type annotation as well, because it's kind of hard for the compiler otherwise to infer module types. But then the point of this is that like with a little bit of this code, you just sort of like load the plugin, and it compiles this for you, and now you have the handle message function of the plugin, and you know exactly what type it is, right? And then on the other hand, the plugin on the side is literally just what I had before of like literally just handle message function, right? So that's kind of nice, and everything's sort of well typed. And if something doesn't type, I get a nice type error that informs me about this. Does that make sense? Okay. So let's talk a little bit, just a few more minutes, about the implementation of how this works. So OCaml plugin generates the source code by taking a UML file and wrapping it into this first-class module. So you need to do a little bit of sort of syntactic extension just to make this work as a first-class module. And it extracts the compilers and libraries that were bundled into the executable. And it compiles the wrapper using dynamic link, which we've seen before. And I want to sort of quickly talk about how that works, because it's sort of like, I think it uses a neat trick. So we've seen that dynamic link sort of allows you to run something at top level and then executes, but it returns unit. So there's really a way of returning something very easily from this dynamic linking. But what we really want is sort of this load plugin function, which takes a string and returns us this module as a first-class module, right? This is the type we want. So the way this works is it uses exceptions. So you define your exception to be the plugin with this module type. And then when you actually come to load the plugin, well, you wrap it, which does the wrapping I mentioned, and you do the compilation by unpacking and then compiling. And then you load the file with dynamic link, and in the hope that loading this file will raise an exception of the plugin type, where it just gives you the plugin back, and then you can return it. And in the case where sort of like load file does not raise an exception, well, something went wrong and you made a mistake. So you raise an exception yourself. At the wrapping stage, then not only sort of does the wrapping of the first-class module, it also inserts a top-level arrays at the very end, including that module type. And that's sort of just a sidestepping the issue of that dynamic linking doesn't really let you return anything, right? So you just use this exception as a way of returning something. And you could imagine using other tricks to do this too, but the exception has a few nice features that make it more desirable. Does that make sense? Okay, cool. So let's just to summarize. If you think back of the slide it had before about problems of DSLs and these configuration languages, let's think about the advantages that we have of this. Well, first of all, we have like well-understood semantics and well-documented semantics. I mean, if you know OCaml semantics, then like everything's pretty straightforward, and there's no sort of like hidden magic going on there that you are unaware of. You have lots of tooling available, of course, because you can just use your existing dev environments, and you can use your build manager, your standard libraries, your review tools. Everything sort of kind of works the same. Another benefit is that you only need to know OCaml. So in this case, if you know something about mail servers, you can read configurations or write configurations without having to know any detail about how this particular implementation of a mail server works. you can make use of other libraries and external inputs, which is kind of powerful because now it opens up the door to sort of any arbitrary functionality you might otherwise have. Right? So a common idiom of using OCaml plugin is not just with the functions that I mentioned, the function example I showed, but also like using it as a way of sort of sourcing in external input. Like any arbitrary external input, let me reach out to them and sort of let the user define exactly how that works and let me return it as an input. And like this goes as far as like, well, your configurations files can now use other configuration files, and you can sort of like very neatly have a hierarchical order of this. And finally, sort of, it's also like, it's also very easily discoverable now, and you have like a nice tight interface between the plugin and the program, which makes this sort of easy to understand. And of course, you have a sort of at least the chance of having a better culture around it, because now people like have strong thoughts about like the way you should format your code, which is configuration, and you can test it and review it, which is nice. So I also want to mention a few drawbacks. So one obvious one is that it's pretty powerful, and that means like it's also like dangerously powerful, right? Because if you don't trust your users, then OCaml plugin is just not really an option for you, because like the user gets to write some code and that gets executed at sort of like your top level and inside your own process. So if the user is malicious, you can do like all kinds of bad things. So really, you kind of need to trust your users. And that goes even a little further than, well, even if you trust your users, if they make a mistake of some infinite loop or some unhandled top-level exception, well, that directly affects your main application, and that might bring your main application down. So you need to like both like write code, be a little bit careful, but also just be aware that, well, mistakes in the plugin can cause the application to suffer, which is a problem. But in our case, like especially the second point is not much of an issue, because often we use OCaml plugin inside sort of like some form of client that the user runs. And the client talks to the server, and the plugin is inside the client. And if the sort of user made a mistake and like misconfigured its plugin, well, then the client dies, but the server is sort of unaffected, and the user needs to restart its own client, which is okay. Another really tricky point is versioning. So if you have sort of an existing version of your program with some plugins and like say 100 users, and now you want to upgrade your program to also using a new contract to the plugin, now you sort of are in this awkward position of like needing to upgrade all 100 programs all 100 users at the exact same time, which is tricky. And we've built some tooling around to make this better, but it's certainly one of the weaker points. And finally, it's sort of like the downside of what I mentioned as just a slide before when I said, you only need to know OCaml, you don't need to know anything specific. The downside is, well, you need to know OCaml. And that's sort of not always feasible either, of like actually sort of exposing a full programming language to a user who might not be a very technical person, or like maybe the configuration really doesn't need this full expressivity. And so this is sort of, again, a point of like, if you have a very simple configuration or like a fairly static configuration, then this is probably overkill for you, and your user probably like doesn't want to sort of like go through the pain of actually learning OCaml to be able to write a little bit of configuration. So the OCaml plugin doesn't work for everything, but I think it sort of solves this problem of like very expressive configuration in a sort of fairly neat way. And we here at Jane Street have started to use it for a lot of things, and it's like turned out to be very, very useful for us. So that's everything I wanted to say. If you are interested, we have open sourced this, so you can just go to this website and find out more. Thanks.